And I've got a shield. You'll just hit my shield. Okay, everyone who's now watching the recording, it's Logan's fault that I'm not recording. No, I'm just joking.
No, it's
Logan's
true.
like, I'm gonna. All right, so the announcements that you missed are really there. Quickly pause the video if you want. We're discussing slope, and the only thing you've really missed, good gosh, this took too long to get to this point, is that the slope is the increase or decrease in the y, the output, as x, or the input increases by 1. So the slope is 5. Guys, that's really 5 over 1, right? Because 5 can be written as 5 over 1, and we said slope is change in y over change in x, which if you need to make that reminder somewhere, you could write the reminder to yourself that m is what we call slope, and it is delta y over delta x, right? This is how we write it mathematically. Give it some depth. So here's what screws us up. The slope is 4/7. So wait, does this mean that the change in y is 4/7 when the change in x is 1? Yes. Yes, it does. But what's nicer for us to say would be actually the change in y is 4 when the change in x is 7. So when you're asked, when you given an equation like this, what's the slope? It's 4/7. And if I asked you, what's the rise and run? Well, you could say, well, the rise is 4/7 when the run is 1. Or, because 4/7 is kind of gross, you could say, oh, the rise is 4 when the run is 7. Because slope is rise over run. Rise over run. Okay, the dumb teachery thing is like, so let's say you're asleep, right? You have to rise before you can run. Like, you have to get up before you can run. So you have to rise before you can run. That's like, you don't. My dogs do, but you don't. So, last one we're doing like this. If you're given slope in like a decimal form, nah, we don't like that. That's the same as saying y is 1/3 x, because we can convert decimals to fractions. Or if you just remember the 1 digit repeating goes over a 9, this is also like saying y is 3/9 x. It's the same, right? 1/3 and 3/9. So we could say, okay, delta y over delta x. This is the easiest way to talk about slope. Just write that slope fraction out. All right, it's either 3/9, like rise, run, or 1/3, or whatever. So, like we talked about last week, all of these relationships are proportional because they do not involve, anyone remember? Oh, ooh, that was like a tie. You've already talked today, so I try to be fair. Hit us with it. There's not an extra number. She's right. I'm just trying to get her to say one more word. Or words. Zoe? There's not what? Yeah, the Y is isolated. Sebastian? There's no extra number. You're right. There's no extra number added or subtracted. That's all I was trying to get you to say. It's like added or subtracted. I think you just like, you were already thinking it, so you didn't think you needed to say it. So guys, if we had a situation like y equals, I'm going to change the order that I write this in though. What if I give you y equals 5 plus 2x? That's the same as saying y equals 2x plus 5. Right, I'm just writing it in a different order because there's a story to go with this. This is my super secret private arcade. And to get into the super secret private arcade, sorry, I've got some Ready Player One, like still floating around in the back of my brain that I just kind of want to go play old school video games. It costs you $5 in admission. So please write this down. It is $5 admission to get into the super secret arcade. And then, because the games are old, they're expensive because we have to fix them all the time. And then, it's $2 per game. If it's worth it, you'll pay it.
So it might not be worth it.
I mean,
Yeah, I'll pay the $5. I walk in.
look, I go to some places and pay $1 per round. Not per round, but like per like reset of the game for pinball. I pay $1 for pinball. Yeah. I mean, I used to go to Pins a lot because they have pinball machines. Where? Oh yeah, I've been to Level 1. Yeah. Dude, if you think Level 1 is sweet, go to Pins. Although all of these places are bars, so let it be on record. I'm not telling minors to go to bars. I'm saying go play pinball. Pinball's sweet. Yeah. So, how we would then model this on a graph, please set up an XY axis. I know you can't see where mine goes. I made mine big the wrong way. Is I would start at, so y, right, x, start at 5. 1, 2, 3, 4, 5, boop. Because 5 is our y-intercept. I mean, if we're talking about video games, we gotta add some boot noises. And 2 is our slope, or our m, which is really 2 over 1. Because anytime it's a whole number, we know it's really over 1. So we go up by 2, over by 1. Up by 2, boop, boop, over by 1. So if I go there and I play only 3 video games, or sorry, not video games, arcade games, my cost will be, okay, $5, $7, $9, $11. And this is what we call graphing slope-intercept form. As I said, rulers are convenient. So then if it said graph the line, of course we connect these and make them a line. That would be 413, right, if you did another. You don't really need a calculator on this, so... So, I'm going to go different sheet because I didn't leave myself much space up here. If you have colors, let's pull out some colors, but I'm going to start a different sheet. And we're all going to practice graphing in slope-intercept form by graphing these 2 lines. And actually, then I'm going to give you some more lines to graph. Yeah, is there like, do people have colors or no, not really? Because I was going to say we could color code these things and use the same colors as each other if we wanted. Well, I mean, you could use colored pencils for your math notes. So I'm going to use my ruler and make a big old XY axis. Guys, I will warn you, we're going to use some negative space of, like, potentially both axes. So I'm going to leave some negative space for both axes. Yes, make it 4 quadrant. I'm probably going to make a couple of my quadrants bigger than the others because we don't use the other ones as much. Sure. I mean, that's pretty much what I was doing. Oh, I got tons I can share, too. I'm not running out anytime soon. And then it helps when we make these big graphs, if we just to remind yourselves, put a Y up on the Y-axis. Also, we always put arrows because we know that things do not end just because we cannot see them anymore. Right? Like, the world is not flat. It does not just drop off over there. That's the horizon. And actually, your graph is not complete. Like, even if you don't even know what to graph yet, until you give it a scale by indicating what one tick mark is.
And are we going to, can one thing probably only be one?
I'm using the small side of my graph paper, so I'm for sure just going to go 1 to 1.
Oh, I didn't even
Question?
realize that there was a small side.
Depends on your graph paper, but yes. What are you thinking, Ivan? No! We're going to talk about why we don't have to here in just a moment. I mean, we can. But today I was going to focus... Well, stick with me for a moment. And then in like 10 minutes, if I don't loop back to you and ask you if we've answered your question, ask it again. Is that a deal? What? What are you laughing at, Colin? Yes. At my shields, if you would. But I should just make like a target on...
That would actually be fun. Throw it.
Pop up like whack-a-mole.
Wait,
Alright!
let me see.
If we're graphing y equals 2x plus 3, I'm going to do it in blue. So guys, I'm going to write these things above my graph so I remember the lines that we did graph. We will also write them beside the graph. So I'm going to write y equals 2x plus 3. The way we start graphing is by starting with, not the slope, even though it's almost what always comes first. We start with the y-intercept. So, Ivan, when you said, are we going to solve for x and y, that's kind of a weird question to ask because solve would indicate like there's a problem to solve. We don't know what this is graphing. It's just a graph, right? Now, it might be graphing like ice cream and toppings or pizza and like, we don't know what y is, whether it's like prices or something like candies, something. So there's nothing to solve yet, but what I think you might have been asking is, are we going to solve the x and y intercepts? Which, yes, we are. We always start with the y-intercept, which is always the number that's added or subtracted on. Now, because we moved kind of quickly, and I think it's on our first paper, but I want to make sure that we write it out nicely. All of our slope-intercept form graphs are going to look like y equals mx plus b. And we wrote this on the other paper, but where m is your slope, b is your y-intercept. So our y-intercept here is 3. So we're going to go to 3 and put a point. Our slope is 2, or 2 over 1. So we're going to go up 2 over 1. And if you made the slope triangle, right, you could see the rise run of 2, 1. We do that again. Boop, 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 boop. Now, I could keep doing this for a long time, or I could just use my ruler and extend that line. But if I keep extending up this way, am I ever going to get to the x-axis? No, because the x-axis is down here. How could I go down? Sophia?
You go down 2 and then over 1.
Yeah, we do the backwards of everything. So down 2, but instead of right, we go left. So I keep that same pattern, but I reverse it. Right? Flip it and reverse it. I think that's a Missy Elliott song, if I'm not mistaken.
Who?
Missy Elliott. I'm old. It's official. I'm old.
Hey,
Somebody just come.
I've heard the name. I've heard the name. I've heard of it before.
Okay, not part of your homework, but I'm not going to take the time to inform you on who Missy Elliott is. She's like, was as popular as pretty much any artist that you could like say like is popular right now. But yeah, like back when Missy was making music, she was a name like Drake, right? Like you would say, like you people just knew who it was. We're not doing this. This is math class. You guys get me off task enough already. I'm just depressed that you don't know who this is. So then, once you have a few points, use a ruler, line up nice. Now, hold up. Here's my trick to make sure your line looks nicer. Watch. Eyes up on the screen real fast. Eyes up on the screen. Watch what I do. For a minute, I'm just going to really quickly go 2, 1, 2, 1, 2, 1, 2, 1. And try to make a point kind of far out. 2, 1, 2, 1, 2, 1, 2. Just like, and you should be able to see if all of them look like they're correct. And then your end points are almost like the most important points to get lined up with. And then we draw our line. Take a moment to do that. What's up, Logan? It's that's my apology for you telling me to record and me not hearing you. Yes. Look, man, take what you can get. Yeah, see, next time when you want me to record, just throw that back at me. So, if you would like to label this line, sorry, my camera is kind of not flat. Somewhere on the line, either down like near the bottom or up near the top or wherever you are, you could write y equals, no, 2x plus 3. Now hold up. The x-intercept. Darn. I have to go down 2 over 1. But to get to the x-intercept, I only want to go down 1. What if I only can go down 1 instead of down 2? Like, if this is the triangle that I make, instead of this triangle, like, right, I'm just trying to draw it the other direction so we can compare the... Well, crap, instead of going over a 1, what would this over be? A half! Yeah! So, guys, that point, that x-intercept, your x-intercept, well, -1 and a half more is -1 and a half. -1 and a half. Look at the delivery. That's pretty sweet right there. So guys, you can always, you don't have to just stick to like the 2, 1, 2, 1, 2, 1. You can do it in portions. What instrument is that? Did they repair it? What is it? I wonder what case that was. I was like, it almost looks like you could fit a set of bells in there, but I don't think you're a percussion player. Represent. Yeah, 'cause she's not here right now. Yeah. All right. Does this make sense of now we know our, well, we knew our y-intercept was 3 just because the equation tells us, but now we know our x-intercept is -1.5. Cool? I feel like I'm losing some of us. On your own, graph 3x minus 1. Oh, well, okay. I mean, you could have. Fine, challenge. If No, I did not start at 0. I started here. Here's my origin. 1, 2, 3 over. You probably would rather have this long than this long. Yeah. This is never going to make it to you. Oh! Well, it made it to Sebastian. I've got one. Well, now he's going to break it. I've got one last one, but this one's like ready to break. This is like one of the super old orange ones. Guys, rulers are like $1. Get your parents to buy you a ruler. I've got rulers you can borrow, but then of course we have to do the whole cleaning thing. So if you need to borrow a ruler for real, they're over there in the very top right shelf, but then you got to wipe them off with your wipe when you're done. Okay, so they're literally just right there across the room in that very top right shelf next to the saltwater taffy box. It's not taffy, it's a tracing paper, so don't think that's candy, it's not. I know. No, it's actually really expensive. Tracing paper is not cheap. So, like somebody pointed out thinking I was graphing wrong, if there is my origin, I start at -1, because that's our y-intercept. Our slope is 3, so we go up 3 over 1, up 3 over 1. I did that a bunch of times. Now, can anyone tell me what this now shows now that we've graphed 2 lines together? We did this already. You just don't know that that these things are tied together. So I'm about to blow your mind. We need like a mind blown button. What is that point? So wait, is it 11? So it's 411? But what is that point? Gents, scooch, like, you need to move where your bag is. The what? Of? It's the, now be careful, no, you're just making stuff up now. It's a what? You're just making stuff up now, too. You were right until you reached the point of me asking for more that you just had to start yanking out of thin air. This is where the equation or expression 2x plus 3 is equal to the equation 3x minus 1.
What's it called? Oh, I remember when we did that.
Remember when we algebraically would say, okay, solve this system, we'll subtract 2x from both sides, we'll add 1 to both sides, we'll solve this algebraically? Guys, check this out, and you don't have to do this with me, but just watch what's up. If I just copied what I wrote up here. If we subtract 2x from both sides, then we get 3 is equal to 1x minus 1. And then if I add 1 to both sides, x equals 4. But wait, there's more. If we now take the x equals 4 and plug it into either of these equations, I'm going to use blue just because I'm writing in blue right now. Instead of 2x plus 3, we'll have 2 times 4 plus, my brain is getting confused. 2 times 4 plus 3, which is 8 plus 3, which is 11, because that is your y equals, because this is the line. No, there is no more. That's it. Oh, wait, but wait, there's more. If we plugged this in to purple, we'd get the same answer. We would get 11. So sorry, I think some of this writing was off the screen that you could not see, but if we take the x that we solve algebraically and plug it, this is what we were doing 2 weeks ago, I think, at least 1 week ago, when we were solving systems algebraically. Okay, maybe it was 3 weeks ago. Like, what? We've done this. Now we're doing it with graphing the lines. Does this make sense? Everybody get your computer out. No? I got a Desmos game for you. If you don't want to play it, fine, but it is a game. You're going to try to land the plane. Yes, you are actually... So, Desmos is connected to the Columbus Metropolitan Airport, and you are actually going to land real-life planes, and if you do it wrong, we don't want to know what happens. I'm completely not being truthful right now.
I want to see the big plane go boom boom.
No, you don't. That's not nice. All right, in your student homepage, there should be an activity called Land the Plane.
Ooh. How original.
How original. You are going to be asked to land the plane that when you start, is not going to hit the runway.
That's so sad.
So you will start here.
Do you have anonymous mode on?
Yes, I do now.
Yay, I must see my weird name. No. Yeah, I want to know who I am. Yes.
Good afternoon, Phoenix. At the class change, I see Hazel Collins, Kayla George, and Luke Hoover in the remote office for just a moment. Thank you.
You need him? Good, take him.
Steal him.
See, like I texted her and I was like, come get Logan. I said, no, I'm just joking.
Steal him away. No.
Man, I should send this recording to some of your parents. Listen to what your child says at school. You can't. You gotta just hit next. So yeah, then slide 2. I only got 4 of you guys logged in so far, by the way. Slide 2, we'll start to actually use some math like what we have been doing. All right, for a minute, I want to say nothing, and I would like all of us to say nothing. Actually, for probably about 5 minutes, just while you play with this and see, do you understand at least as much as I would like you to understand at this point about slope-intercept? Those of you watching the video, I'm going to stop recording so you're not just staring at my face and our screen that has nothing going on. So yeah, if you're in green group, we'll play this with you guys tomorrow. You can't. You just got to move on. Oh my gosh, let me pause my video.